Welcome to Machines That See, New Frontiers in Computer Vision. In this episode, we synthesize key insights from 68 groundbreaking papers published on computer vision and pattern recognition on June 17, 2025. From generative models to privacy in medical imaging, this exploration reveals how advances in machine vision are shaping science, history, and society. This is AI Frontiers. Today's presentation navigates the ongoing revolution in computer vision. The journey will uncover how machines interpret and create visual worlds, highlight the major research themes driving the field forward, and spotlight paradigm-shifting discoveries. Expect technical deep dives, discussion of ethical issues, and a forward-looking perspective on AI-powered visual intelligence. This episode serves as your comprehensive guide to the latest advances in computer vision. Computer vision is the branch of artificial intelligence that enables machines to see and interpret images and videos. Core tasks include object detection, image classification, and scene understanding. Its applications span diverse domains such as healthcare, robotics, the sciences, and the humanities. At its foundation, pattern recognition involves extracting meaning from raw pixels and data, bridging artificial intelligence, mathematics, and practical problem-solving in the real world. Generative and diffusion models now occupy center stage in computer vision research. These models empower machines not only to recognize, but also to imagine and create new visual content. Lin and colleagues introduced cost-aware routing for efficient text-to-image generation, dynamically balancing output quality and computational cost. Diffusion models are being applied to tasks such as image restoration, relighting, and the synthesis of medical data. The core principle involves reversing noise to generate realistic visuals, but achieving a balance between efficiency and output quality remains a critical challenge. A second defining research theme is the integration of multimodal learning and vision language systems. Artificial intelligence increasingly combines vision, text, and contextual understanding to achieve human-like perception. The PRL model by Liu and collaborators demonstrates interleaved vision-language reasoning, while Huang and colleagues' Dense 360 project fuses omnidirectional vision and spatial cues. Attention mechanisms are central to aligning and integrating different data types, enabling models to interpret images in context with language and other modalities. A third major focus is the pursuit of robustness, efficiency, and scalability for real-world deployment. Vision models are being optimized to become faster, smaller, and more reliable. Wang and colleagues utilize knowledge distillation for efficient model compression, while Zhang's MOTE model demonstrates the compression of large multimodal networks for edge devices. These efforts aim to ensure robustness against noise, adverse lighting, and novel environments. Model compression techniques allow small models to closely mimic the performance of larger ones, supporting AI applications on resource-constrained hardware. The fourth key theme is multisensory fusion and the adoption of new data modalities. Researchers are moving beyond traditional vision by integrating data from sources such as LiDAR, dual-pixel cameras, and tactile sensors. Li and collaborators have advanced sensor fusion for 3D reconstruction and depth estimation. Multisensory artificial intelligence enhances navigation and object understanding, with sensor fusion combining the strengths of different technologies to unlock richer and more context-aware machine perception. Theme 5 addresses the societal impact of computer vision, spanning healthcare and historical research. Breakthroughs in vision models have transformed medical diagnostics and enabled new approaches to studying historical documents. Zhao and colleagues highlight privacy risks inherent in generative medical imaging models, while Lin's palette system unlocks text in centuries-old maps. The development of large datasets and benchmarks is crucial for driving progress and ensuring accountability. The stakes include not only accuracy and performance, but also fairness and ethical responsibility. Across the field, several critical insights have emerged. Hyperlocal transformers have set new standards for historical text spotting, as demonstrated by Lin and colleagues. Vision transformers now excel in the analysis of scientific data, as shown in the work by Jahin and team. Frequency-based membership inference attacks have exposed privacy vulnerabilities in medical artificial intelligence, as presented by Zhao's group. The integration of multimodal data has increased robustness and interpretability, while the creation of new datasets and architectures continues to accelerate progress. The latest methodological trends in computer vision include several breakthroughs. Diffusion models generate images by reversing noise, achieving high realism. Transformers have become essential for modeling long-range dependencies and patterns in images. Synthetic data generation and augmentation techniques address data scarcity and diversity challenges. Model compression and distillation enable deployment of advanced AI on edge devices. Multimodal learning now bridges vision, language, and other sensory modalities, opening new possibilities for artificial intelligence. The first paper spotlight features the work of Lin and colleagues, hyperlocal deformable transformers for text spotting on historical maps. The palette model employs a hyperlocal focus, outperforming previous methods on challenging map data. This approach combines transformer-based attention with the synthetic data generation capabilities of SynthMap+, enabling the processing of over 60,000 maps and unlocking more than 100 million searchable text labels. This research establishes a new benchmark for digital humanities projects and for domains where annotated data is limited. The second spotlighted paper demonstrates how vision transformers have been applied to end-to-end quark-gluon jet classification in particle physics. Jahin and team show that vision transformers outperform classical convolutional neural networks when classifying jets from calorimeter images. These models leverage attention mechanisms to recognize long-range spatial patterns, and the researchers provide benchmarks and datasets for both the physics and artificial intelligence communities. This work illustrates the capacity of AI to advance scientific discovery and structured data analysis. The third spotlighted paper by Zhao and colleagues addresses privacy vulnerabilities in medical image diffusion models. By analyzing mid-frequency reconstruction errors, the proposed attacks more accurately detect whether a given image was part of a model's training set, outperforming existing membership inference techniques. This work reveals significant privacy risks in generative medical imaging models and highlights the need for robust privacy defenses and auditing tools. These findings are essential for the safe and ethical adoption of generative artificial intelligence in healthcare. Looking to the future, several directions are set to shape computer vision. Researchers are striving for greater efficiency, scalability, and sustainability in model training and deployment. Robustness remains critical, particularly for safety-critical and real-world applications. Multimodal and cross-modal integration is deepening, enabling richer and more nuanced interactions. Ethical challenges, including privacy, bias, and transparency, demand ongoing attention. Continued collaboration between artificial intelligence, domain experts, and society will be essential for responsible progress. This review deck was generated using advanced artificial intelligence synthesis tools. Summarization and analysis were powered by GPT 4.1 from OpenAI. Text-to-speech was produced using OpenAI's TTS system, and visuals were described with Grok image analysis tools. All summaries and insights were reviewed by expert human editors. Nonetheless, some oversights may remain, so listeners are encouraged to check the cited references for full technical detail. References include key works from Lin et al., Jahin et al., Zhao et al., and others. Thank you for joining AI Frontiers. Subscribe to our YouTube channel to stay updated on the latest breakthroughs in computer vision and artificial intelligence. Enjoy in-depth reviews, expert commentary, and a community dedicated to exploring new frontiers in technology. Join the conversation by sharing your thoughts and questions. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive.org.